Um, we're, we're going to start now. So, hello everyone, welcome to today's session. So, this is a live webinar where we're talking about DevSecOps in the age of AI, how modern team builds fast and stays secure. So, this live is being hosted by Nimbus Compute. So let's get started. My name is Ifebi Chomeke, founder and lead DevOps engineer here in Nimbus Compute. I've been a DevOps engineer for over 6 years now, and I've been in software developing for decades now. Under my leadership, Nimbus Compute is partnering with Cygeny. It's a DevSecOps security company that's focused on protecting your CI/CD pipelines and your just practically from your SDSC from software development cycle. So what Nimbus Compute is a consulting company here in the UK. We focus, we help businesses automate their infrastructures, scale their cloud, and deploy securely on the cloud. So our goal is to we focus on no excuses, and we focus on automating the borings and helping businesses scale fast and stay secure. So we're talking about why DevSecOps matters in 2025. So we are seeing AI accelerate everything. A lot of people have been building building code more faster than past years. Developers are like solo building their code on themselves, but now with the help of AI like Cursor and um, Code Cloud, you'll be able to build your code and write your code more faster and deploy while not thinking about focusing on security. So we've seen a lot of deployment coming from developers, like 60% of what, like let's say for example, in the past years, building code was like 10% or 20%, but with the help of AI has been able to help us build code more faster and deploy it. And with that being in place, a lot of companies are missing security out, which is why DevSecOps actually matters in this, especially since AI is getting into, we are being able to use AI to build our code. So that's why DevSecOps matters. And threat is actually evolving. So although we've seen AI has been helping us write our code, at the same time, I would say AI is a double-edged sword because the more we are using AI to write our code, the more attackers are using AI to manipulate and inject malicious code into our code. So let's say, for example, you are using ChatGPT or you are using Cursor AI or using any IDE you are using to write your code that got AI integrated into it, and you are generating code, and more code, you are generating more code. Attackers are at the same time using AI to dictate and manipulate the AI you are using as well. So yeah, so security can't wait anymore because with this pace of us building code and deploying faster, developers are missing out on securities. Like the new developers or the new engineers in your company, attackers are using AI to do phishing, whereby they are doing deep fake videos, manipulating developers into accessing their, because once they get their access to their code, once they get access to their credential, they will be able to escalate and move straight to CI/CD, then to the cloud. So that's why DevSecOps matters in 2025. So this is 25 threat landscape. These are 6 critical attacks vectors targeting modern development pipelines. So we start with AI model vulnerability. we use AI to generate code, right? But you need to understand that there's something we call engineering. This is where you let AI do what you want AI to do or behave such in a way, or be a developer, or be a tester, or wherever you want it to be, or how they want to generate the code. So we are seeing attackers using injection to be able to poison this AI into generating vulnerable code into the code as well. So we're seeing like people, especially people like vibe coders, are writing their code, thinking the code is safe, or without forgetting or not understanding how the AI behaves. But by using prompt injection, attackers are being able to manipulate how this AI behaves and how they generate code, and being able to generate vulnerable code. And also, while generating code, we these developers have been leaving securities like secrets or on plain text, or leaving like a database password on a config file, or using an API like cloud credential they use on a plain text. So without by uh, manipulating the AI issue, they are able to like obtain the credential and be able to go through um, go move on through that way. So the next one is supply chain environment. So we're talking about dependencies. If you look at 60 to 70% of the code we use, or the application that we use, are all depend on open source dependencies. And this is another way attacker can actually get into your code. Whenever you run dependencies, like you want to install like package.json or prom.xml, these are vulnerable. So our code depends on open source, where that could be vulnerable, and these open source could be manipulated by these attackers, and by us, our code depending on these application depending on these dependencies. This is another way attacker can get hold of your code and manipulate your code. From the supply chain, then they move to CI/CD pipeline. Now, CI/CD pipeline is the heartbeat of software development lifecycle. So once they get hold of your CI/CD, let's say once they build, we build your image and push to any container register you're actually using. From there, from the pipeline, they will move from the pipeline to production. So you might like say, okay, how can they actually like manipulate your pipelines or wherever? So from the supply chain, from dependencies, they go from the information, or from the data they get from AI model vulnerability. A developer could leave a config file, or leave a credential, or Azure credential, or AWS credential for his login. I'm leaving a plain text, then forgetting about this. So by manipulating through this, they could get through CI/CD pipeline. Then from CI/CD pipeline, they put backdoor on the artifact. Then from the artifact, the code goes to production. Yeah. On the next phase is cloud misconfiguration. So this, I've seen a lot of engineers leaving exposing secrets. When we think that, leaving our repo to private keeps us safe, but a lot of private repos are pushing like sensitive files to the GitHub, thinking they are safe. But when these attackers, they live on your repo for like 256 days, living quietly without you actually even detecting. They also posing as your engineers with the credential they already stole from the developer. They can pose with a deep fake video. They can act as an engineer, or as a director or a manager, to obtain more higher data information. So cloud misconfiguration is very, very important, because we see so many uh, resources. Let's say, for example, in terms of networking, there's networking. We're not using networking to segment resources, and also also being exposed, like we having resources that's supposed to be on a private IP has a public IP, and also over privileged rules as well, and insecure default. Then goes to the secrets exposure. So this is where we talk about secrets. A lot of developers who are writing their code, they leave the secrets on a plain text. This is very important. And before pushing the code to the GitHub, most these developers do not forget to git ignore some sensitive like config files or data information they actually have. So by pushing this code to GitHub, you have already exposed the secret, like and also leak the API keys and expose tokens. So identity-based attacks, this is where these attackers steal the information and move on from there and moves to later movement. So later movement is when they goes from your CI/CD pipeline, then they goes into the cloud. They can move around the resources if there's no network segmentation, if there's no this privilege in place, or because you configure your cloud misconfiguration was like have so many your content your container register with no with public IP. This can lead to identity-based attack. So here is how attacks really happens. First of all, it starts with initial entry, compromised dependencies or exposed secrets. So we focus on SCA dependencies. Like I said, most of our applications depends on open source dependencies, and this is the entry point. Whenever we run, we build our Docker file to build our image or to download dependencies that will make our code to actually work. We are actually inviting attackers through vulnerabilities, through dependencies, because these dependencies are vulnerable and could actually be injected with malicious attack. So that's the first entry. And the next one is pipeline takeover. So once they actually go in through the dependencies and to expose secret, they can actually, so from the exposed secrets, they already obtain your secrets, your information, your GitHub accounts, your username and password. They will be able to do what? To take over the CI/CD pipeline. So imagine the developers when they write their code and the attacker get hold of the exposed secrets, then you will be able to use it to log into your GitHub. From there, you can actually manipulate for a DevOps engineer information, and because DevOps engineer have access to repository, CI/CD pipeline, because they build the automation. From there, they will take over CI/CD pipeline, and they will inject backdoors or manipulate your CI/CD that goes to your production. So from there moves to later movement. So from CI/CD pipeline, with the credential they're able to obtain from CI/CD pipeline, because I've seen so many engineers leaving secrets on open text without using environment variables, or without using vaults, or without using GitHub secrets and variables, or without using key vaults. They leave secrets on a plain text. So with the secrets or with the information they obtain from the CI/CD, they will move to the later movements. Later movement is where they can actually move around your resources. And this is where we're talking about, like, if there's no network segmentation, or because if there's a network segmentation, once they are branched to one particular resources, that's in a separate VNet or VPC, because you still need an authentication for them to move to a different VNet. But I've seen so many configuration on cloud where every resources are being put on one the same VPC or one the same VNet. And from there, they're assigning, like, resources have upper hand roles without like assigning them this privilege and other things. So from there, they can move around and go into your key vault and actually even obtain your database password and username and password, and be able to like break into your database password. Then from there, they actually move. So payload delivery, this is where they actually move to deployment. So because they have already like get hold of the CI/CD pipeline. The pipeline that actually deployed to production, they have already implemented backdoor to the application. So that's to the uh, to the image built by your pipeline. So once it's deployed, let's say you're deploying on Kubernetes or wherever your application is going live, they've already uh, implement backdoor into the application before it goes to deployment. And once it's go to deployment, they can watch your application. They can actually extract data and also deploy backdoor to it. And also that is where you see things like identity thefts. You can actually see ransom and etc. Yeah. So we're going to talk about DevSecOps blueprint, security embedded at every stage of pipeline. So looking at these blueprints, you're going to understand the full DevSecOps and why DevSecOps is so much important in our SDLC workflow. So we start with the static application security testing. We have to embed security inside our code. Every pull request that's been made from feature branch to develop need to scan the code and make sure the code is up to standard, because using tools like Cygen or using tools like Sonar Cloud can actually scan your application from day one. So when the developers actually building their code and everything, before any code is actually being merged to the develop branch, pipeline is going to trigger. Pipeline that's containing your like Sonar Cloud or Cygen will be able to trigger and scan the future branch that's about to merge to develop, making sure that the code they actually write is up to standard and is not vulnerable, and there's no sensitive information or there's no secret or anything like that. Also, you see something like we call secret detection. So secret detection is where developers push code. If your Sonar Cloud couldn't detect the secret from the application, secret detection is able where it actually scans your code to make sure if there is any IMA keys leaving on you left on your code, or if there's a password, if you do the API keys that actually left on your code, because sometimes developers forget to actually ignore these resources, these config files, and also forget to use environment variables or forget to use vault as well. So, and uh, GitHub and GitLab actually have a tools where that actually scans your repository all the time. So whenever there's a secret that actually push to your repository, it actually scans your repository, constantly making sure there's no secret actually being exposed. Then comes the SEA dependencies. DevSecOps is actually embedded in SEA because, like I said, major application actually depends. I would say 60% of application actually depends on open source dependencies. So we embedded DevSecOps on SEA, making sure that the packages or the dependency is actually pulling if it is if there is any malicious or if it's actually vulnerable and if it's actually up to standard. So it makes sure it scans this code to up to standard. Then we go to container scanning, the image vulnerability check. So after even before the build actually happens, this is where the SE actually scans your code. Then after the build, it actually finished building before the image is actually pushed to any container register or any Docker desktop or Docker hub or anywhere or any private register you push your image or any GitHub container register. You make sure that you use like tools like something like Treeview, because Treeview focus on scanning your image, making sure there's no vulnerability on the image or making sure there's no API key left on inside the, or build with the east image. It's a very, very actually important. Then we move to IAC security, infrastructure validation. So we make sure that your DevSecOps make sure that even your IAC, because so many infrastructures depends on IAC like Terraform, Ansible, Terraform, Ansible, Bicep. So DevSecOps is actually embedded on these, making sure the infrastructure you're actually provisioning on the cloud meets the standard, and also there's no there's no resources actually being provisioned with a public IP, or making sure that policies actually meet the policy and compliances before any infrastructure is actually provisioned. But if it doesn't actually meet up the standard, the pipeline is going to stop, and it will not be able to provision on the cloud. Then we move to policy enforcement. So with this infrastructure, something we call policy as code as well. DevSecOps make it possible that we're able to automate the whole security by using policy as code, making sure that every resource is like up to standard with what we're actually going, configuring policies like using our open policy agent to configure the resources, and everything is actually embedded in our pipeline before the infrastructure is provisioned, and also drift detection, making sure that resources that actually we build or the resource or the infrastructure we actually write is exactly what we are provisioning on the cloud. So if there even someone manually or attack against your resources and manually create something or add an account or add a role, your pipeline is going to detect this drift and be able to alert you on time. So we see sign build. I've seen this like underrated but most advanced way of securing your pipeline or securing your image. So sign build is whereby your pipeline builds your image and pushes it to any private register you're actually using. But before you actually push it to any register you're actually using, it's going to sign the image and make sure, so you know that your pipeline is the one that actually signed this image. So even this image is being modified by an attacker, by you looking at, this image have actually been modified because it's not actually signed. Do you understand? So signing image is actually a huge milestone on DevSecOps, because you're not going to deploy what your pipeline did not sign, if that makes sense. So we talk about secure deploy. So this is where even when it goes to production, we have to make sure that this application is actually what our Kubernetes have the least privileged access to even pull image from our container register, and our container register is actually on a private endpoint and is actually isolated on its own resources. As well, we talk about running runtime monitoring. So even when the application goes live, we are constantly be monitoring the Kubernetes or monitoring the application for any misbehave way, or if there is any backdoor, any transferring of data or from an external URL or something like that. So this is DevSecOps blueprint, and this is how DevSecOps is actually embedded from all the SDLC workflow, from the shift left to the production and to the monitoring. We talk about DevSecOps pillar here. So what this actually means is, earlier as how you're actually going to dictate this code, what are the stages that you need to follow to make sure your code is actually up to standard, because we're talking about shift-left security, early vulnerability detection. So on the IDL or the Visual Studio or any editor your developer is actually using to build code, tools like SideGenie or other tools, security tools, can actually be embedded on this editor, making sure that code we're actually writing is up to standard and there's no vulnerable inside the code. And also using the ignore, making sure these developers are not pushing sensitive information to GitHub, and also using like environment variables or using vaults to store the secrets. And also, so being able to dictate this issue or tackle this as early as shift left is actually more cheaper than, because I would say this thing, security is not a last option. Security is a must. It's something you need to your develop. It's good to let your developers have security mindset from the beginning, from day one, and this makes helps in tackle the problem and reduce the issue as much as it can, because it's actually more cheaper to take care of the issue as early as I can than in production, because once it's good, because you're thinking about later, and later is going to be very much expensive. We're talking about securing our CI/CD. So it's very, very important, because CI/CD is the heartbeat of the SDLC, and every company is actually depending on SDLC, CI/CD. So being able to make sure that everything is actually versioned, and your CI/CD, there is no plain text, there's no secret being left on your CI/CD workflow, your leaving it on a plain text, and also making sure that whoever that is making sure that even the deployment on our production is actually manually approved, and whoever is actually approving it need to be everything needs to be traceable, and whoever is actually approving it have the least privilege. By focusing on this, we'll be able to restrict any amount of damage, and that's why this is DevSecOps pillar. Then we talk about IAC security, infrastructure as code. So if Terraform is a code, and many companies are depending on code to provision their resources on the cloud, so we need to think about the way we write our infrastructures, making sure we are modularizing it so that it can actually be reusable, and also leveraging if you're using Azure, you're leveraging key vault, making sure you store your database password, API keys on the key vault, and also making sure there is no Git initialized on your local computer. Everything needs to be fully automated, building the CI/CD pipeline for it, and also we're focusing on embedding policy as code as well, making sure we scan our IAC, like using tools like DevSec, making sure there's no everything is actually up to standard. And this, so we're talking about container security, image scanning, and runtime production. So your image needs to constantly be scanned before you actually push it to your container register. And it's very, very very, very important that you scan your image using tools like Cygenin, or using tools like Trivi to scan your image to actually detect if your image is contains sensitive information. And also, whenever you are writing your Docker file that will build your image, always use two-stage build, so that instead of actually like your image being up to like 1 gig, 2 gig, 3 gig, you'll be able to reduce the reduce the size to like 200, 300 MB. This is actually reduce the amount of even if is your code is actually manipulated. So by using two-stage build, it's good for security mindset, so that it reduce the amount of attack or damage done on this. So we talk about governance. This is where we talk about policy as code enforcement. Like I said, embedding policy using governance, configuring, making sure that our infrastructure is up to standard, is following certain policy or how we want it to be. We are configuring this, and we also use making sure zero trust, never trust any. So even though this developer, always use MFA or use authentication, making sure you verify who is who before you actually do anything or anything like that. So we're talking about so we have seen DevSecOps pillar. Now let's look at AI plus DevSecOps the future, because AIs have been we have seen AI in so many tools that DevSecOps use these days, and like tools like Cygenin got AI machine learning embedded into it, although it helps developer to focus on or it helps DevSecOps engineers to focus on building the framework and building the data, while machine learning. So we're looking at automated detection. So whenever there's a pull request that's coming from feature branch to merge to develop, your pipeline is going to trigger, your security DevSecOps pipeline is going to trigger scanning the code. Once every code is actually scanned, so there's amount of data breach, there's amount of vulnerability, there's amount of code you need to change. there's amount of code you need to change, AI be able to detect these issues and actually the words uh, suggest or generate in a like a standard code that you actually use to replace, because um, this actually slows developers more, slows them down. That's why we use AI to actually generate or detect any vulnerability and also suggest fix as well. So that's it. So AI power IAC, we have seen AI that's actually um, generating our infrastructures and making sure that our infrastructure is up to standard, and making sure that our infrastructure is actually following policy as well and compliances as well, making sure there is no exposed secrets or there's no sensitive information left on plain text, making sure everything is actually getting ignored before you provision to the cloud, and also automating this using policy as code as well, embedding governance and compliances. Our infrastructures will be up to standard. Then we talk about machine learning anomaly detection. So when our code goes live to production, we have dashboards where we are monitoring our application, making sure everything fine. So instead of constantly monitoring all this, AI can actually read logs, knowing whenever there's a spike on latency or whenever there's a malicious movement or uh, unauthorized access into the production, or if there's uh, a backdoor being injected to our application that goes to production. So AI actually use by reading this log, making sure everything is actually fine. But if there's any vulnerable or any movement actually detected, we're able to alert us and let us know, and or even take control as well. So yeah. So we are shipping, like we are seeing developers building code and shipping more faster and deploying, and there's so many tools that we actually use for this. So we're looking at container variable scanning. So tools like 3V scans your image. We've talked about 3V here. It actually scans your image, making sure that before your image is actually pushed to container or any private register that you actually use, before your image is actually pushed, it scans your code, making sure there's no sensitive information left there, or making sure there's no vulnerability inside your application. And also tools like Sagini as well. Sagini is an application tools that uh, contains both 3V, both that's SASTA, SCA, also CI/CD pipeline, infrastructure scanning, and secret detection all in one. It's like all in one tools, and also it has AI integrated into it that helps you even when sensitive information or even where a malicious code is actually detected, AI can actually suggest auto fix. So whenever you approve it, you actually fix it and document it. Do you understand? So you see that everything is actually traceable and audit. So we're looking at static application code analysis, using tools like Sargent again, or using tools like Sonar Cloud. Whenever there's a pull request coming in from your feature branch to your develop, it all actually scans your code, making sure there is no API keys, making sure there's no data with password left behind, and making sure the code is actually up to standard. So we're talking about policy enforcement. So we're using tools like OPA, Policy Agent, to scan our IAC, infrastructure as code, and also secure CI/CD pipeline tools like CI/CD. We use CI/CD pipeline. We use GitHub Action. So we GitHub Action. GitHub Action is actually integrated with. If you want to use a private register from GitHub Action, we use GitHub Action container register, and also you can as well reference your secrets and leave your secrets and information on the secrets and variables. Then reference it using environment variables, without exposing or leaving your secrets on a plain text. So we talk about signed image storage. So before your image is actually being deployed to production or deployed to or wherever you want to deploy your application, you make sure the image that you actually deploy is actually what your CI/CD sign. So we embed sign in like Signal signs your image. So we embed in your CI/CD, everything is fully automated. So whenever your CI/CD is actually built, before you actually push the image to the private register, it signs your code, making sure this. So by the signing it, we make sure that okay, this is what our CI/CD pipeline produce, and we only deploy what our CI/CD pipeline produce. And also by using version instead of using latest, everything is actually traceable, like version 1, version 2, version 3, instead of using latest. We make sure that we're actually deploying what our pipeline produce and sign. So manager orchestration, this is where we talk about deployment on Kubernetes, making sure that Kubernetes only have least privilege access to pull image from a private register, and also using making sure that whoever that's configuring or whoever is setting up uh, the namespace or deploying on Kubernetes, we make sure that we have least privilege, and also we're using network segmentation, because this is how network segmentation can actually reduce risk. And also it's important in DevSecOps is that network segmentation, instead of compiling the whole resources on one VNet, we can actually separate each environment with different VNet and subnet. So even if when an attacker actually bridging into your cloud and actually manipulate or get hold of one of your resources that's in one section of the VNet, they will still need authentication, authorization to be able to actually break in other resources. So this is why network segmentation is very, very much important. And I've seen so many companies, so many engineers misconfiguring their cloud, whereby they are actually using one separate VNet for actual everything, which is not the best practice. So I've seen benefits of teams so by DevSecOps works in teams, and by focusing on these teams, we can actually catch issue before it actually goes to production. And 75% of this reduction in critical vulnerability. So by working in teams, by working in collaboration, you'll be able to make sure that you're following the policy and following the rules and be able to dictate it. And what I mean by working in collaboration, working as a team, is where you make sure that your developers have security mindset instead of just generating code, because your developer also have access or have access to your repository. So if they don't have security mindset and they don't have security mindset, and the information is actually being pushed to your GitHub, like the sensitive information, this is where attacker can actually get hold of that information and then moves from there to other places like the CI/CD pipelines and also to the cloud, and they move to your production by implementing backdoor to your artifacts that goes to production. So I will make sure by following this collaboration and team, you'll be able to deploy faster. So since AI is generating so many code, making sure their code is up to standard in DevSecOps is actually fully automated and being pushed. So you can see actually faster delivery, because when everything is fully automated, pipeline does the whole work and developers just focus on writing the code while focusing on the security mindset as well. So, and also we're talking about compliance automation. We make sure, so when you see stats, let's say, for example, when Trivi scans your image, make sure there's no vulnerability on that. So you will see that it's going to post comments and documentation and make sure everything is just traceable and auditable, making sure that for your compliance is meeting SOC 2 and also meeting 27001. So by focusing on this, we are making sure that everything is fully automated, and our and security is actually embedded from shift left to production, and being able to make other engineers or developers have security mindset. It actually reduce the amount of vulnerable or amount of attack that goes to your application, but not being able to treat this as early as you can. And later, because like I keep saying, security is not a last option. It's something that have to start from shift left, because once it goes to production, it's going to cost more than 10 times more than what it's going to cost than it's from shift left. So yeah, we are question, and you can actually ask if anyone have any question. If you want to ask any question, you can drop question on the chat. Let's see. So someone asked what is exactly multi-stage building Docker and how to make it. So multi-stage building Docker actually helps you to be able to reduce the size of your build. So by not utilizing multi-stage build, your image actually image size actually, if you don't use a multi-stage build, your image size actually this is where you see this image with up to 2 gig, 3 gig. But when you utilize multi-stage build, so when you're writing your Docker file, you have to define so that it have to be multi-stage build. In that way, your image is going to reduce to 200 MB, 300 MB, and by having a smaller size of image, it reduce the amount of attack, it reduce like you'll be able to like reduce any malicious or any vulnerabilities inside the image. So yeah, any team that adapts with multi-stage build actually reduce the amount of attack that comes that you actually get on your application. So someone's asked, what's the difference between class security and DevSecOps? So difference between class security and DevSecOps is that class security actually focus on on cloud, where by making sure the teams or the group have appropriate roles and appropriate least privilege, and also but DevSecOps focus on your SDLC workflow, that's on your software development life cycle. In this way, it's actually focused on, so DevSecOps focus on DevOps, making sure DevOps or developers are actually shipping fast and staying secure and safe. But cloud security actually focus on more into cloud engineering roles. Any more question? So For engineer, if you want to get complete DevSecOps implementation roadmap with these tools, workflow and best practice, or you know what to do, just comment roadmap, and we'll be able to send you this video and also this roadmap for this webinar. And for company, and if you want to book a free security posture review and discovery vulnerabilities in your current pipeline, you can actually book a one-on-one consultation from our website, nimbuscompute.com.uk. So yeah.